this picture is a senator, James Inhofe from Oklahoma. This was taken in February of 2015. He was making a speech on the floor of the US Senate. It was a very cold period in February 2015. They just had a big snowstorm in Washington, D.C., and they were having a debate. I don't know if it was specific legislation about climate change, but he brought in a snowball and essentially tried to refute the idea of climate change by, saying, look how cold it is. I've got this snowball here. It's snowing here in Washington, D.C. at this moment. And so he was kind of implying that, climate change is not happening because of that. And so, you can't really get caught up necessarily in the day-to-day things when you're looking at how things are changing in the climate. And as we go through the presentation, you'll see that I don't focus so much on the day-to-day. Next slide. So here's some actual, this is data. This is kind of the big picture. This is a graph that shows the global surface temperature from 1880 until 2020. And you can see that I think this data comes from NASA. I believe this is a NASA data set. On the left-hand side, it shows the temperature relative to normal. In this case, the normal period being 1880 to 1920. And you can see around the turn of the 20th century, temperatures, you see the blue line going kind of up and down. That's, the year-to-year change. And you can see that there is variability. It changes from year to year, but the red line is more of a mean, more of an average over a longer period of time. So you can see the trends. And that's, what scientists, in particular climate scientists, are looking at. And so you're seeing a little dip after 1900. It kind of goes up in the 20s and 40s. It levels off after that. But at some point in the mid 1970s, there's this steady climb. Again, you could see that there's still ups and downs there, but averaged out, there's still temperatures that are, global surface temperatures are still going up at a fairly steady rate. Okay, so we can go to the next slide. So, how do we see these changes? And again, these are bigger picture things, things that are more dramatic, things that you hear about in the news. One thing that scientists have seen and measured is change in Arctic sea ice. And if we can go to the next slide. This is a graph. The person that put this together is a postdoctorate student by the name of Zachary Lab. And he does have a Twitter account where he posts graphs like this, which is, I think he's just ZLABE. I would suggest following him on Twitter because he's got a lot of interesting things. So this graph looks at the extent of Arctic sea ice, and it typically melts during the summer, and it's at its minimum in September and then rises. So you kind of see a dip and then it goes up. And if I can move my stuff here so I can see. So the different colors there represent the mean change in sea ice by decades. So the purple is 1980s, the blue is 1990s. The first decade of the new century is in that kind of teal color. 2010s is the white. So you can see the trend is there for less and less sea ice in the Arctic by year. And the 2021 was the second lowest on record this past year. And I know one of the theories that some climatologists have looked into is to whether the warming and this loss of sea ice is potentially having an impact on jet stream patterns in the atmosphere. They haven't really connected all the dots on that, but that's one area of research. So that's one fairly dramatic change that they're seeing. And when you lose that ice, it becomes tougher and tougher each year for the ice to build back to the same extent during the winter when they do have more ice And so it's kind of this feedback loop that makes it easier year after year to lose more sea ice. Next slide. And here's another topic that's been in the headlines. I put California wildfires, but I could have just put Western wildfires, because within the last week there was a particularly bad wildfire in Colorado, near Rocky Mountain National Park there. California, they got a lot of headlines. If you hit the next button there, they've had 400 million acres plus that have burned because of these wildfires. Now, certainly you can't tie everything, all the fires and everything, to the change in the climate. But the climate scientists do believe that more intense droughts and heat in California have certainly made those wildfires worse than they would have been otherwise. So next slide. And then hurricanes. We've had a very active season in the Atlantic, and I don't think we're done yet. In fact, click the next slide here. And I had to change this one because when I made this presentation and was putting the final touches on it, we'd had 10 tropical storms or hurricanes make landfall in the United States so far this year. And of course, this past week on Wednesday, Hurricane Zeta made it 11, hit the Louisiana coast. They've had 5 storms in Louisiana just this year. And in terms of the research on hurricanes, tropical systems, and climate change, it's not necessarily, again, that we're going to get more hurricanes. It may be more that, the research is leaning toward storms potentially being stronger because of a warmer climate, storms having more moisture available to them, creating more flooding. One thing that we've seen that may be tied to changes in the climate is rapid intensification. A number of storms, not only this year, but in recent years, have strengthened very rapidly as they've moved, in particular, over the Gulf of Mexico. I think it may have been Epsilon. I was at work and it became a depression, and the next day, literally by the end of the next day, it became a Category 3 storm with 130 miles per hour winds. And we've seen more of that happen in recent years. Okay, can we go to the next slide? So now, how does this impact us in central New York? What are we seeing? We're not seeing those kinds of dramatic changes, whereas, they're seeing all the sea ice melting and the wildfires and hurricanes. What we're seeing here in central New York is a bit more subtle. So let's take a look at some of those things. Let's dive into some of these numbers and go to the next slide here. Oop. So how do we want to define some of this stuff? What kind of time frame do we need to look at? Again, we're not looking at the day-to-day changes. We're not, looking at days, like a week ago when it was 80 degrees and, for a day. So meteorologists need some type of a time frame. Next. So we're not looking at days, we're not looking at months or even a year. Next slide. When we look at averages and try to put things into perspective, we look at time frames by 30-year stretches when we're trying to gauge changes in temperature and precipitation. Okay, so next slide. And actually, at the end of this year, we will have a new set of averages. We work off right now, currently, technically, the averages between the years 1981 to 2000. That's the 30-year period. If you were to watch me do the weather in the evening and I show temperatures and show how today's temperatures compare to normal, we're comparing it to the normal as it was defined between 1981 and 2000. And here's a breakdown of what will be the new temperature averages when we're done. I mean, I took this through September. And notice that these new averages that are going to be, 1991 to 2020, we're not warming equally. In fact, there are some months where we're cooling. Now, January is a bit above normal now compared to the past 30-year average, but February, March, April are cooler. Now, February, my speculation there is that we're skewed quite a bit by February 2015, which was our coldest February and also our coldest month ever. It didn't go back, but I'm guessing that may have pushed us below normal. And the interesting thing about March and April is I've had a number of people come up to me, usually in the spring, and they say, you know what, our springs are shorter than they used to be. And spring just takes forever to get here. And it seems like, spring isn't long. We have winter lasts longer, and then it seems like we go right to summer. And it would appear that the numbers kind of back that up. The March and April temperatures, this new set of averages is going to be almost half a degree below the 1981 to 2000 averages. But then after that, notice that May, June, July, August, September, those averages are all going to go up when the new round of averages come out. And I ran the numbers for October. We still have technically 1 day left, but we're going to be about 9/10 of a degree above normal. And the same people that tell me that the springs seem to be shorter or come later also say, boy, our falls have been great. They've been great recently. And that's part of it. We're seeing warmer Septembers and Octobers as well. So next slide. And then, then you show a graph like that, and then people start to say, well, it was hot before. Back in the 30s, it was hot. In Syracuse, the hottest day ever, July 8th, 1936, 102. And booked end around that is 101s on July 7th and the 9th. Okay, so yeah, there was a heat wave. We had 100-degree days for 3 straight days. But again, you don't want to look just at a day or a number of days. You want to look at a longer period of time. So if we go to the next slide, if you then take a look at the top 20 hottest Julys and see where, the decades kind of rank, 10 of the 20th hottest Julys have occurred since 2000. So over the last 20 years, the record, the period of record in Syracuse is since 1902. So I think it's 118 years, but half of those have occurred in the last 20 years, and 6 have occurred since 1910, and only 4 occurred back in the 1930s. So yeah, it was hot in the 30s, but we've had hotter July since then. In fact, this July was the hottest July on record in Syracuse, and the hottest month ever as well. Okay, next. Oh, and of course, winter takes center stage in terms of what we're known for, I think, winter weather. So if we go to the next slide and take a look at the temperatures during the winter months of December, January, and February. And I broke it down into those 30-year averages just to show you the change. So this is roughly over 10, 20, 30, 40, 50 years roughly. You can see that the first 2 30-year averages, no real change there. But then the last 3, including this current one, we've seen a increase each decade. It was a little bit more pronounced when we added the 1990s in there in that 1971 to 2000 range, but it's been steady even beyond that. Okay, so can we go to the next slide? Snow, temperature is one thing, but snow is another. This is a picture of me taken near Redfield in Oswego County, which is home to lake effect snow, and you can see it piles up. Made a drive up there one day, and so they get a lot of snow. We get a lot of snow here in Syracuse as well. And here is something I found, if we go next slide, in terms of our snowfall. So when I averaged out those decades, since the average in 1951 to 1980 to now, our winter temperatures have gone up almost 2 degrees, yet in that same time period, our seasonal snowfall total has gone up more than the foot. So go to the next slide. So that raises some questions. How does something like that happen where we have warmer temperatures and yet we have more snowfall? Well, my theory is that one theory is that you get storm systems that come in, a storm track that's a little farther north than they used to be, and you get snow, but then you start to see changeover to sleet, freezing rain, and rain as temperatures warm. So your storms that you're dealing with are warmer storms. They start out as snow, and more of them go over to this mixed precipitation. And here's some other numbers that kind of back that up in something else. If we go to the next slide. Back in that period between 1951 and 1980, I look back, and the number of days that we, kept snow on the ground, had at least an inch of snow on the ground, was 88 days every winter. I know it probably feels like it's more than that, but that's the average back then. And now we only have an inch of snow on the ground for 80 days during the winter. So we're increasing the snow, but it's staying less. And again, it can be partly due to the storm track. It could be, more thawing that occurs after storms. We're just not keeping that snow on the ground as much. And that's, again, a function of the temperature, which is now during the winter 2 degrees warmer than it used to be 50 years ago. Okay, next slide. So I'm going to bring this graphic back, and I do that because I'm going to get into a couple of more specific examples here. And we talked about March and April's being a little bit cooler than normal when we figure in the new averages. And it does have some practical implications, the cooler weather that you can get sometimes in March and April. So if we go to the next slide, keep that March and April in mind. Apples. Most people love apples. Not everyone, but most people, I think, like apples. I had an apple before we started the presentation. I talked with Peter Fleckenstein, who manages Beacon Skiff, which is pretty much the biggest apple orchards here in the immediate Syracuse area. And he, has been working in those fields for years and years. And if we go to the next slide, his biggest worry with the weather is the extremes in the spring. I showed you the graph that showed temperatures are below normal or becoming cooler compared to normal now in March and April. But in that space, we're seeing more extremes. I go back to 2012 in March. We had a string, it was one of our warmest Marches ever. We had 70, even 80-degree weather in the mid to latter part of that month. And what that does is brings out the apple buds early. And, we know that you're not going to have 70, 80-degree weather sustained from the end of March right through spring. And sure enough, it gets cold. And that makes those apple buds more prone to frost. So, he's seeing more extremes. And if you go to the next slide, that means they have to do things to prevent that from happening. One of the things they have, this isn't specifically from Beacon Skiff, but they do have a few windmills in their valleys there. And what that does is mix up the air so the coldest air doesn't just settle into the valley and cause frost and nip the buds. So that's a big concern to him, is that change that we're seeing in terms of the springs and more variability in those temperatures. Now, next slide. So now I'm going to get into a little bit on Oneida Lake, and I saw Tom Brooking in on the chat here, and I know he's going to be speaking in about 15 or 20 minutes, so I don't want to steal his thunder here too much. But I think I got information from one of his colleagues, Christopher Hotaling, and he emails us the lake temperature, Oneida Lake temperature every week during the summer, so we can include that in our boating forecast. And a few weeks ago, I said, can you pass along what the lake temperature, what the highest lake temperatures are by year? And he did. And here's some interesting things that I found. They've been keeping track. Go to the next slide, please. Keeping track, the Cornell Biological Field Station in Bridgeport, the lake temperature since 1975. And in the years from 1975 to 1998, there were no years, those 23 years, there were no years where the water temperature reached 25 degrees Celsius or greater. That's 77 degrees Fahrenheit. So not once. Now, go ahead, next slide. In the 21 years after that, from 1999 to this year, there have been 8 years where the temperature was at least reaching, the highest temperature that the lake ever got was at least 25 Celsius or greater. And 5 of those have occurred in the last 10 years, including this year as well. Next slide. And what are the implications on that? Well, you start to get the warmer waters, and you also create more blue-green algae. If we click the next slide, I believe it's pronounced, and Tom may verify this, cyanobacteria, the blue-green algae. And, in practical senses for people that want to take advantage of the lake, you can't swim when you get, issues like that. Oneida Shore is closed from time to time during the summer because of things like that. Next slide. And again, this is probably something Tom may talk about, but apparently the warmer temperatures will affect different species of fish. This is the bowfin, which is the swamp trout, which would potentially be impacted as these temperatures get warmer in the lake. And, Oneida Lake being a big fisherman's lake, that's going to have an impact on people. Next slide. Next, I wanted to show this map. One of the things climate scientists have determined using the computer models is, in the future, there's going to be more heavy precipitation events in a changing climate. We're already starting to see that. And this particular graph breaks it down into regions. And this is the percentage change in the amount of precipitation in very heavy rainfall events. So that means the heaviest 1% of daily events. So it doesn't necessarily mean, like, for example, here in central New York, that on a year-to-year basis, we're getting more rain. Our heaviest rainfall by year all occurred in the 1970s. But individual events are increasing 71%. That's since that's the period 1958 to 2012. Next slide. And there's a breakdown in the Northeast, and you can see during the decades leading up to the 1990s, it was kind of up and down, and now just in the last 20 years, we've seen an increase. I mean, you could take a look. I don't like to pinpoint one specific event, but last year on this day in Halloween, we had almost 2 inches of rain. It was our wettest Halloween day ever by more than an inch. And we're getting more of those types of rainfalls, not only here in central New York, but also the Northeast. So let's go to the next slide. So I wanted to look at the numbers more closely. So I looked at our top 40 wettest days. And again, the time frame I'm looking at, our period of record is 118 years. And this comparison is, the percentages are all increased versus if everything was spread out and there was an even distribution of rainy days. If we had the same amount of rainy days, every decade. But in reality, since 1990, over the last 30 years, we've had almost 30% more than you would expect rainy days. And the numbers are above 30% in the last 20 years and also in the last 10 years. So what does that mean? Let's go to the next slide. we're seeing an increase in the water that's going into the Great Lakes in the last 100 years, not 10 or 20 years, but over the last 100 years, there's a 10% increase in the water that's going into that watershed. And it's projected to increase another 10%. So if we go to the next slide, and we're seeing problems with that. And again, it's not all climate change necessarily. There's other things going on, but in 2017, 2019, we saw record lake levels on Lake Ontario. And it's estimated that homeowners, like you see in this picture from one of our newscasts, suffered damage to $36 million combined in those 2 years. And that's just for Lake Ontario. That doesn't include the other lakes. And, it causes problems with shipping. It's estimated that there was losses of $250 million in shipping because the lake levels were too high, made it tougher to navigate because of that. So those are the types of changes that we're seeing, in real time. We're seeing the changes to Lake Ontario, Oneida Lake, which you'll hear more about shortly. We're seeing those numbers change with temperature going up as well. And so, those are the things that, I was able to research in and take a look at. So if we go to the next slide. So those are the things that are out there that I'm seeing. And now in the remaining time that I have, I want to just kind of open it up to questions that people may have. Now, I may not have all the answers because, again, I'm a meteorologist, not a climatologist, but I will try to help. So, Kristen, I don't know if you had anything specific that you saw come over the chat line.
Here we go.
There you go.
One question that I had was that Moore Lake effect. Is that related to the fact that the lake is freezing later, so you're getting more ability for moisture to build?
Well, lake effect for Lake Ontario never freezes. There's been because Lake Ontario is deep. It's about, I think it's either 600 or 700 feet deep. It's one of the deeper Great Lakes. And yes, there's ice that you see maybe on the shoreline around Oswego or Rochester, whatever, but out over the open lake, it does not freeze. So take that out of the equation. But yes, I mean, if your winters are warmer, then your temperatures of the lake would be warmer, which opens the door for more lake effect. But as we were talking before the kids came in here, there are many variables when you're trying to forecast the weather. You could have a lake that is 2 or 3 degrees warmer than it normally is, but if you don't have cold air aloft coming over the lake, you're not going to get lake effect. There's all this potential energy, as you talk about in science, in that lake. You've got all that warmth that's there, ready to heat the air to create clouds and create snow. But if the air coming over it is not cold enough, you're not going to get those clouds. You're not going to get that precipitation as well. So you're juggling a number of variables, but there is potential. I mean, there was one year, I think it was the winter 2007, 2008. It was a very benign winter up until the end of January. It was mild. The Lake Ontario was very warm. I forget specifically how warm. And then the cold finally decided to come in. And this was right around the time of the Super Bowl. It was early February. And it was one of the more epic lake effect. It was really one event that went over about a week's worth of time. The lake effect moved around a little bit from time to time, but essentially stayed up toward Oswego County. And there were many locations that in that week of time had more than 100 inches of snow. The most, I think the high total was Redfield, which is up in the Tug Hill, had 142 inches in, I think it was 7 or 8 days. So, that, you might be able to tie that to certainly tie that to a warmer lake in that situation.
Another question that we had on the chat line. Growing up, there was always a January thaw and then a return to cold, but the snowpack would only melt a little. But
Mhm.
now it seems that there is no long-term snow coverage and the ground is exposed most of the winter. Has this been impacting the way icing and surface interactions with precipitation occur now?
In terms of changing the storm tracks and things like that, I'm not sure, but certainly it does seem outside of a few years that most of the time you get you get these snowstorms and you get the snow like we typically do during the winter, but then you thaw and that snow melts. And I think that goes back to the one graphic that I showed, or the two graphics, one that showed that we're increasing the amount of snowfall, but at the same time not as much, not as many days with snow on the ground. If you go back to, the 1970s, I was growing up in the 1970s, and part of this may be my perspective as a kid, but certainly there were more winters there where, you'd build up a snowpack in December and it seemed like it would be there for most of the winter, where you'd have more than 100 days with snow on the ground. But there's certainly there's more variability now in the winters. There's the snow is not sticking around as long, and I could have put in slides there because that impacts ski areas. They can't rely on natural snow as much, because it's not on the ground as much, so they have to rely on making snow, which costs money, and that affects their bottom line. So that's something that the ski areas have to deal with in the changing climate.
All right, that was, are there any other questions out there? People can,
Miss Reichart,
yes.
this is Mrs. Leonard. So can we just have everybody, I had put this into the chat, go back to that original link. I put the link in the chat so that we can watch the video that the Homer School students made on the action planning, because I kind of snipped that out on accident.
Sure.
Yeah, so right after immediately following this, if people can go right back to that original link, that would be great in between the two sessions.
Perfect. All right, we do have one more question. How does this year's drought compare to others? And does that have implications for the winter weather?
Let's see. Our droughts are different than, when we get a drought, it's not like when they get droughts out west and they get wildfires. That's not, the main concern. For us, it seems like whenever we have a drought or get into drought conditions, it's usually an agricultural or hydrological issue. I know this year in particular, it wasn't too bad on the farmers. It was more, we were hearing from people that rely on wells to get water. When it becomes dry, their wells dry up and they have to dig deeper to get water. In terms of what this means as far as the winter is concerned, I haven't looked to see if there's any connection in terms of dry summers and winters. One of the things that we'll look at for this winter, and we'll do our winter outlook in a few weeks. One of the overriding patterns would probably be the La Nina, which is cooler than normal water temperatures in the equatorial Pacific, and those are the numbers that I'm digging into right now. But I mean, the drought, numbers, that brings up a good point, and that's something that I'll probably look at to see if there's any connection there as well. To see, in years where our rainfall was down 10% in the summer or 20%, what were the following winters like? I don't have that answer to that question, but that's that's something that may show a pattern for the winter. So I'll have to see.
We'll stay tuned to hear your forecast in a couple weeks then.
Yep.
Are there any other questions from the participants?